Adventurous kids explore with education and learning what a wildlife is in the Everglades. I want to explore the Museum of Discovery Science. What plants do butterflies like? I want to know about Key West. Adventurous kids, learning and fun. Adventurous kids!
Today we're going to
tell you about the electromagnetic spectrum.
The electromagnetic spectrum is the range of all types of electromagnetic radiation. Radiation is energy that travels and spreads out as it moves, and the electromagnetic spectrum includes everything from very long radio waves to extremely short gamma rays. What distinguishes one type of electromagnetic radiation from another is its wavelength or frequency. Wavelength is the distance between the peaks of a wave, while frequency is how many waves pass a point in a given amount of time. These two properties are inversely related. The longer the wavelength, the lower the frequency, and vice versa.
The electromagnetic spectrum was discovered through works of several scientists over time, but the foundation was laid by James Clerk Maxwell in the 1860s. Maxwell developed a set of equations now known as Maxwell's equations that described how electric and magnetic fields propagate and interact. These equations predict the existence of electromagnetic waves that travel at the speed of light, leading him to propose that light itself is an electromagnetic wave. Later, in 1888, Heinrich Hertz experimentally confirmed Maxwell's theory, generating and detecting radio waves, a form of electromagnetic radiation. This discovery marked the beginning of understanding the full electromagnetic spectrum, which includes radio waves, microwaves, visible light, ultraviolet, X rays, and gamma rays.
At the low frequency end of the spectrum are radio waves, which have the longest wavelengths. They are commonly used in communication technologies such as television, radio broadcasting, and cell phones. AM radio uses low energy waves. FM radio uses medium energy waves, and TV uses high energy waves. Just above radio waves are microwaves, which are used in radar systems. Certain communication devices and microwave ovens. Moving up the spectrum, infrared radiation comes next. Infrared is felt as heat and is used in everything from night vision goggles to remote controls and thermal imaging.
Next in line is visible light, the small part of the spectrum that human eyes can detect. It includes all the colors of the rainbow, from red, longer wavelengths, to violet, shorter wavelengths beyond visible light, is ultraviolet UV radiation, which has shorter wavelengths and higher energy. UV rays from the sun can cause sunburn, also used in sterilization and black lights. Ultraviolet light is used by powerful telescopes like the Hubble Space Telescope to see far away stars. Ultraviolet light is a type of ultraviolet radiation.
Further along the spectrum are X rays, which have even shorter wavelengths and more energy. X rays are widely known for their use in medical imaging, allowing doctors to view the inside of the human body. Finally, at the extreme high frequency end of the spectrum are gamma rays, which have the shortest wavelengths and the highest energy. Gamma rays are produced by radioactive atoms. When a star goes supernova and in nuclear explosions, and they are used in cancer treatment and to sterilize medical equipment. Gamma rays can be harmful to the human body because they are a very strong type of energy that can hurt our cells and make us sick if we're exposed too much. That's why scientists use special protection when working with them.
Radiation in the electromagnetic spectrum comes from tiny particles called atoms. Inside atoms, little parts called electrons can move around. When these electrons jump to a different place or get excited, they release energy as waves. These waves are what we call electromagnetic radiation. Depending on how much energy is released, the waves can be radio waves, microwaves, ding ding, or beep 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 beep, light, X-rays, and more. So everything from sunlight we see to the radio signals we hear come from atoms sending out these energy waves.
Understanding the electromagnetic spectrum helps scientists and engineers develop technologies across various fields, from medicine and astronomy to telecommunications and energy. Though those waves differ greatly in wavelength and energy, they all travel at the same speed in a vacuum. The speed of light, which is 186,000 miles per second. Spectrum is not just a concept in physics, it's a fundamental part of how we interact with and understand the universe. Thanks for watching.
This episode of Adventurous Kids. Yeah!
Blessed be.
What did you learn today? Adventurous Kids. Adventurous Kids. What was the most interesting fact? Adventurous Kids. Adventurous Kids. Adventurous